3D printing news unpeeled, courtesy of 3dprint.com. And in today's 3D printing news, well, we look at a researcher at the University of Hawaii at Manoa College of Engineering, and that's Assistant Professor Tyler Ray. And what he has done is received a 2-year, $237,000, 916 $237,916 NSF grant. Have you ever noticed how these NSF grants are strangely really specific? No one ever asks for like 300 grand or 250. It's always 237,916. It's really strangely specific sum always. This, by the way, is also exactly the same amount of taxes that Governor Kathy Hochul and her husband paid last year. So if you're wondering where they get those numbers from, apparently that's where they get them from. So this has been a grant part of the NSS Research Infrastructure Improvement Track 4 EPS Core Research Fellows. Now, what I like a lot about this is that it connects researchers with other researchers. The research itself is to do with silicon nanoparticle electrodes in high capacity batteries. Now, batteries, of course, is a very big subject at the moment for electric cars, but the electrification of everything. But you have to look much beyond that. Think about like electrifying a grid, right, and trying to equalize that grid and keep that grid working when there's surges in power because there's a lot of wind, and then there's an ebb in power because there's not enough sunlight. And that kind of thing, and also providing backup power for factories, providing a large industrial power for ships and stuff like this. So batteries have a very, very long way to go from just only being there for just electric cars that we all know. So this research is very cutting edge. It's 3D printing research related to these silicon nanoparticle electrodes. There's been a lot of very promising work here, and through 3D printing, we could really organize, print, and come up with better, more unique conformal structures that could outperform those regular batteries. There's quite a lot of body of research that's been emerging that we could maybe make very low cost, also very, very efficient batteries using additive manufacturing. What I like again about this is that he's going to be working together with the Materials Research Laboratory at the University of California, Santa Barbara. It's a top research materials facility. They have all the toys you could ever want in polymer and metal research. And he's going to be working with Ram Sheshard, who's the Fred and Linda Woody Chair of Material Science there, who's a big shot. So I like the fact that they're trying to combining researchers who essentially kind of work together, and you get lined up and put together to get this grant and work together. And I think, especially in 3D printing, it's a very interdisciplinary thing. It's a very much of a team sport at the moment. And so the idea of having a government grant giving organization kind of semi-forcing people to get money to work together, I think is really good. It gets people out of these silos. We're seeing a lot of university research right now is very IP focused. It's very focused on that one technology silo created around the university, around their inventions. And we know that really a lot of breakthrough stuff, can't be done that way. You need to work together. So I really, really like this. And yeah, the potential for batteries and 3D printing batteries for conformal, for optimal structures is ginormous. It is something that would, if we made any kind of headway in battery 3D printing, that would eclipse a lot of other stuff we're doing. At the same time, a lot of the stuff that's happening commercially in battery 3D printing is overblown and overly optimistic. So we need to be a little bit more, just because there's a lot of potential doesn't mean that that's a commercial type of potential. The next thing is some news by Spare Parts 3D, and that they've worked by the Petroleum Development Oman, PDO. And what PDO and the company did was they looked at 150,000 files and they scored them. They process these files from the ERP system in order to identify which parts were suitable for 3D printing, how these parts are feasible, and how and estimates on the costing. They did this with the machine-based learning software, machine learning software called DigiPart. Now, one of the things that DigiPart does is really cool, I think, is it just takes the names of parts and tries to extract useful information. Now, of course, you'd hope to go a little bit further than this, but just based on the name, it can extract a kind of a useful information as well. And the idea is that this, in a semi-automated way, would really identify a lot of parts. So on the one hand, this shows the huge potential. The PDO, Petroleum Development Oman, is not a huge player in the oil business, but it has a huge volume of parts, 150,000. It's in a relatively remote location. The country of Oman, of course, wants as much of that oil wealth to stay in the country. So it's really, really very, very motivated to conduct repairs, to build new parts, to optimize parts, design them, and 3D print them in the country. So they would love to have, like, an overseeable investment on their part in DED or powder bed fusion that would see them make a lot of the stuff in house. That would be good for the country. That'd be good for the government. It would be good for this PDO and their licensed operating country as well. But that success and that idea of NOx and other oil companies, resident oil companies as well, and commercial big firms as well, to kind of increase their license to operate is a huge thing for them. And it's very, very difficult to set up a whole supply chain in a remote delta region of Nigeria or in an offshore region somewhere else. But a 3D printing supply chain for part of the parts is very attractive. Now, of course, in oil and gas, we also see that interruptions are a really big problem. We can sometimes wait 3 to 6 months or maybe longer for cast parts. And that, of course, if there's a catastrophic failure somewhere, could be a huge, the business case can be instantly made. Now, at the moment, it's not all the software. So the team at PDO had to score these parts and look at them. There was a lot of information missing in the ERP system. There's a lot of information spread out all over the country. This is par for the course. This happens all the time. This information isn't centralized. It isn't well described. Some parts are decades old. Some parts, just weren't incorrectly uploaded. Some parts are in legacy systems all over the place. So I'm glad they put this in this case or this press release and they talk about this, because this is the stuff that people are encountering day to day. Um, but just imagine the potential. Imagine how many millions of parts there are in oil and gas, and how many millions of these parts have to be identified. Um, so there's a huge potential, I think, to make the 3D printing more relevant in 3Your Mind and Castor, DG X, and other companies. If the more automated they do this, and the faster they automate this process, and the faster they let these people identify what the business case is, the more money everyone in 3D printing can make. So I think this is an absolutely fantastic business case. And I think there's tons of these, and all the major energy companies in the world will have a case like this. So I think this is great. But again, they had to do a lot of the work themselves. So ideally, you would want this to be almost completely automated. And that's where the multi-billion-dollar opportunity is. If we can really automate this, then automate the business case creation. So identify the profiles, correctly determine printability, directly determine cost in an accurate way. Um, and then also directly determine what the business case is for this part in a more or less automated way, in a very, very structured way, to be able to identify all of the good business cases and all the data. That would really make our entire industry much, much bigger almost instantaneously. Anyway, so that was the news that I thought relevant was today. Thank you so much for listening. My name is Joris Peels. This is another edition of